This will be our last video in our nuclear chemistry unit, and in this one we're going to talk about the difference between fission and fusion reactions. Nuclear fission is where we're going to take a very heavy nucleus of a radioactive element and we are going to split it into two or more stable nuclei that are kind of intermediate mass. So in this example, we can see that we have an isotope of uranium-235 being hit by a neutron, and that's going to cause it to split into a krypton-93 and a barium-140 nuclide, and it's going to give off 3 more neutrons in order to balance out the mass. So this is the kind of reaction that is occurring in nuclear reactors and nuclear weapons. They use this. Now the difference is in a nuclear reactor, see, these 3 neutrons could theoretically go hit 3 more isotopes of uranium and start this process all over again. And then that would cause what we call a chain reaction. So 1 becomes 3, 3 becomes 9, etc., etc. And at some point, it can hit a set where it's called critical mass, which is where enough of these nuclides are undergoing this reaction so that it won't stop. And that's basically what a bomb does, is it just doesn't stop. With nuclear reactors, they have rods of something like bismuth that will absorb these extra neutrons so they can contain the reaction. Because as we can see down here, the amount of energy that an atomic bomb can produce is like 9.87 times 10 to the ninth, which is like 9.87 billion kilojoules per mole of uranium used in the reaction. So we need to control that amount of energy, otherwise it decimates the area. Nuclear fusion, on the other hand, is where you're going to take 2 lighter nuclei and you're going to get them to combine in order to make a more stable nucleus. So in this example, 4 atoms of hydrogen will combine to form an atom of helium and will give off 2 beta particles, again, or actually these are called positrons, in order to balance the equation, and gives off a lot of energy. This type of reaction produces 5 times as much energy as nuclear fission, and it has the benefit of not producing radioactive waste. This is the kind of reaction that occurs in the sun every day to provide the energy we need on Earth to survive. Unfortunately, we cannot use this reaction on Earth because it also requires a lot of heat to start the reaction. It requires temperatures near the temperature of the sun, which is 10 to the 8th Kelvin. So we have not found a way to get this to either occur at room temperature that we can control, or come up with a way to generate that amount of heat to start the reaction and actually get more energy out of it than we put in.